Hello guys, how are you today? So today I'll be explaining the chemistry AS level AMS. So there are some questions, I'm gonna speed through them because they came in the last AMS and they're relatively easy to solve. So let's start with the first question. Atoms of different elements have different number of subatomic particles. Which of the following ions has different numbers of all three subatomic particles? So what you're supposed to do is you're supposed to find, first of all, the number of protons for each, number of electrons for each, and then finally the number of neutrons for each. Why? Because the three subatomic particles are protons, electrons, and neutrons. So for the first one, we have 7 protons, we have 10 electrons, and we have 7 neutrons. So this is wrong because they're the same. We have proton and neutron that are the same. Move on to the next one, magnesium 2+. We have 12 protons, also 10 electrons, and also 12 neutrons. This is wrong. S2-, it's what, 16, 18, and 16 again. This is also wrong. So finally, last but not least, we're left with this one. This is 19. And then, how many electrons do we have? We have 18 electrons. And then, what's the number of neutrons? We have 20 neutrons. So this is our answer because all three subatomic particles are different. Now, the mass number is the number on top for each of them. Okay. Atomic number is the number in the bottom for each of them. The number of protons is the same as the atomic number. Number of electrons is the atomic number Z minus the charge, okay? And the number of neutrons is what is the mass number A minus the number of neutrons. So first, let's start. The mass number here is 137. Atomic number is 56. Number of protons is 56. Number of electrons, since it's neutral and doesn't have a charge, it will have the same number of electrons and protons. And then finally, number of neutrons, it's going to be 137 minus 56. That's going to give us an answer of 81. Let's move on to the next one. It has a mass number of 27, an atomic number of 13. Since it's an atom, it has no charge. It has the same number of protons and electrons. And the number of neutrons in this case is 27 minus 13, which is what? Which is 14. Now, what's the mass number here? It is 80. What's the atomic number? It's 35, which is the same as the number of protons, which is 35. And now the number of electrons is what? Is the atomic number, 35 minus the charge. So it's going to be here 35 minus 1, which is what? Which is 36. So this is how much? This is 36 electrons. And now finally, the number of neutrons is 80 minus 35, which is what? Which is 45. Let's move on to the next one. 5626 Fe2+, okay? So what is the mass number in Fe 5626 2+? It is very simply 56. The atomic number is 26, which is the same as the number of protons, 26. Now, the number of electrons is the number of proton, or atomic number, 26 minus the charge. So 26 minus 2 is 24, so we have 24 electrons. Now, the number of neutrons is how much? The number of neutrons is the mass number minus the atomic number. 56 minus 26, that's going to be how much? 30 neutrons. Let's move on to question number 2. Which of the following about titanium are true? We know that it has a mass number of 48. It has an atomic number of 22, which is the same as it's the atomic number, which is Z, which is the number of proton, which is the same as what? Which is the same as the number of electrons. Why? Because it is an atom. Now, how much is the number of neutrons? It's very simply 48 minus 22, which is 26. So which of the following is our correct answer? The last one is our correct answer, that the number of neutrons is 26. Let's move on to question 3. Copper Cu is a transition metal that has 29 protons and 35 neutrons. What is the atomic symbol of copper Cu? First of all, it's Cu. It has 29 protons, meaning its atomic number is 29, and 35 neutrons. So if you add the neutrons and the protons together, 35 plus 29, you will get 64. So it should be 64. What? 64 is the mass number, or it's the same, it's the number of nucleons. So 64 Cu29, this is our final answer. Let's move on to question number 4. The surface of a metal object is struck by electromagnetic radiation of increasing energy. Electrons are observed to be emitted when the energy of the photons is this. So this is what the energy of the photons. We also have Planck's constant over here, and we have the speed of light c. They want us to find what the wavelength. What is the wavelength? What's the equation to find the wavelength? Very simply, wavelength is equal to speed of light over v, where v is the frequency. Okay, and v is equal to what? V is equal to the energy over Planck's constant. So what's the energy in this case? It's 4.19 times 10 to the power of minus 19 over Planck's constant, which is 6.63 times 10 to the power of minus 34. Put it on your calculator and you will get that the value of v is what? The value of v is 6.32 times 10 to the power of 14. Okay, perfect. Now let's just erase these. Now we have what? We have v, which is the frequency. And we need to find what? We need to find the wavelength lambda. Wavelength lambda is the speed of light, which is 3 times 10 to the power of 8, over v, which is what? Which is the frequency, which is 6.32 times 10 to the power of 14. Of course, after solving, you're supposed to get an answer, which is what? Which is 4.75 times 10 to the power of minus 7 meters. But do they need our answers in meters? No, they need it in nanometers. So what are we going to do? We're going to change from meters to nanometers very simply by multiplying by 10 to the power of 9. After multiplying by 10 to the power of 9, you will get 475 nanometers. So this is our answer. Now, this is in between which two values? It's in between 424 and 491. So that means this is blue. Let's move on to question number 5. Okay, what does it say in question number 5? Which of the following are true about isotopes of thorium? What do you need to know about isotopes? You have things that are the same and things that are different in isotope. Meaning that they will have the same what? They will have the same number of protons, meaning the same atomic number. And because they have the same number of protons, they will also probably have the same number of what? The same number of electrons. And because of the same number of protons and same number of electrons, they will have what? They will have the same chemical properties. However, when we are dealing with different, we know that you are adding what? Neutrons. So you will have a different number of neutrons, which leads to a different number of mass, or a different mass number, which then, because mass is what? Mass is a physical property, which will lead to what? Which will lead to a different physical, like they have different physical properties. Okay, so that's a quick summary of isotopes. They have the same physical properties, no, but they have the same chemical properties. They have the same number of protons and they have different number of neutrons. Let's move on to question number 6. What does it say? And let's wait for it to load. Which of the following are true about 2px and 2py? First thing you notice is that they both have 2. Since they both have 2, this means they have the same energy level, which is denoted as N. Whereas, you can also notice that they're both in P, so px and py. Due to this, you can say they have what? They have the same sub-level. Now, when they have the same energy level and the same sub-level, what can we say about them? We can say that they are degenerate orbitals. So they are degenerate orbitals and they have the same energy and sub-level. Let's move on to question number 7. What does it say? Complete the table to determine the number of protons, neutrons, and electrons. First of all, number of protons is the atomic number, Z. Number of neutrons is A minus Z, which is mass number minus atomic number. And number of electrons is Z minus the charge. So over here, it's going to be what? It's going to be 35, right? Let's fill them, first of all, column by column. So it's going to be 35 protons, 56 protons, and 17 protons. Let's move on to neutrons. It's gonna be 80 minus 35, which is what? Which is 45. Then we have 137 minus 56, which is 81. And then we have 35 minus 17, which is what? Which is 18. So the number of neutrons are 45, 81, and 18. Now, last but not least, a number of electrons. They are the atomic number minus the charge, so 35 minus 0 is 35. 56 minus 2 is 54. Okay, and then finally 17 minus 1, that's gonna be what? That's gonna be 18. So these are the final answers for this question. We have 35, 45, 35, then 56, 81, 54, and then what do we have? We have 17, then 18, and then 18 again. Now, let's move on to question number 8. Okay, here is where we go to something we learned in AP Chem. This we took it last week, so now we need to apply it. Use the 1s2 notation. If you don't know how to do the 1s2 notation, I cannot help you further. I can just explain to you how you can do it. There's 2 ways of doing it. The first way is the Hans rule, which is doing 1s, then 2s, 2p, then 3s, 3p, 3d, then 4s, 4p, 4d, 4f, and let's stop until here. Then you have to take this one. Whenever the arrow is odd, you will add a number. When it's even, you take the same as the one before. So this one is odd, you will add 1. This is even, you will take only 1 as well. Then you go to the next one. It's odd, so you will add 1 more. So now you will take 2. This is even now. You will take how much now? You will take 2. And then if you continue it, 5s, 5p, 5d, 5f, whatever. How much will this be? Because it's even 5, you're going to add how much? 1, so 3. This is one way of doing it. This is known as Hans rule. Or sorry, I think, I forgot what it's called, but this is a rule. Another way to do it is like this, very simply, to do ss, then ps, ps, then let me actually give more space. So ss, then ps, ps, then d, ps, d, ps, then f, d, ps, f, d, ps, okay? You can do it like this. Then you can label 1, 2, 3, 4. This is 4. 5, 6, 7, 8. Okay, then for P, you start in the second energy level. 2, 3, 4, 5, 6, 7. D, you start in the third. 3, 4, 5, 6. And then for F, you start in what? In the fourth. So 4 and 5. And now you have to remember that S can hold 2 electrons. P can hold 6. D can hold 10. And what's it called? And F can hold 14. So this is the electronic configuration. Now we need to continue them. If you guys don't know how to do electronic configuration, this is on you. You guys should practice. You guys should know how to do it by yourself. Now, one thing about electronic configuration is that there's exceptions. What are these exceptions? We have only 2 exceptions. They are chromium, Cr. How are you supposed to denote it? So chromium, Cr, you're supposed to denote it by, first of all, it has 24 electrons. So you're supposed to denote it by 1s2, 2s2, 2p6, this is already 10, 3s2, 3p6, 4s2, this is how much now? 20. Then, wait, is it 20? Let me count. Yeah, it's 20. So let's go back. Let's stop here. 3s2, 3p6. Then what do you put? You write 4s1, 3d5. Why do we do this? Honestly, this is for us later to understand. I think mainly because they want it to be more stable. So they put more single unpaired electrons, because as you know, the more unpaired electrons there is, the more stable it is. Okay, so this is why they did this for chromium, Cr. Same thing goes for copper. Cu, how much is copper? Let me just check. Copper is 28. So it's gonna be what it's gonna be. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, and 3d10. Okay, so these are the exceptions that you need to memorize. Chromium, it ends with 4s1, 3d5. And copper, Cu, it ends with what? With 4s1, 3d10. Okay, so these are the only exceptions you need to know. So for copper, it's going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, okay, 3, oops, my bad, then 3d10. So now we move on to Fe3+. It is 1s2, 2s2, 2p6, 3s2, 3p6, and 3d5. So this is the answer. But now, oops, I put the answer for both. But now we need to find out why it ends with what? It ends with 3d5. We start. Let us write the full regular electronic configuration of Fe3+. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d6. Okay? So now if you add everything, you're supposed to get what? You are supposed to get a total answer of 26. But how many electrons did we remove? We removed 3 electrons. We always start taking electrons from the S. So this goes by. This is already 2 gone. How much is left to take from this one? 1. So 6 minus 1 is 5. That's why it is 3d5. Now, for Ca, I answered it already. It was 4s2. You guys are supposed to know this. Now, Se2 minus. So he has 34 electrons or protons, and we need to fit them. So let's do it together. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. How much is this now? This is now 20. Then 3d, 10. This is now 30. Then 4p, 4. Okay, so this is now 34. Let's add them all together to check. 2 plus 2 plus 6. Plus 2 plus 6 plus 2 plus 10 plus 4. So you're supposed to get an answer of 34. But how many electrons were taken away? 2 electrons were taken away. Oh, my bad, sorry. My bad. 2 electrons were added, so you're plus 2 electrons. Where will we add them? We will add them over here. So what will it become now? It will become 4p6. My bad, because 2 minus means that it's gaining electrons. Plus 3 means that it is losing electrons, okay? So that's it for question number 8. Let's move on to question number 9. So here you should know that S orbital looks like this. A sphere, P orbital is a dumbbell, and then D orbital has 2 shapes, either the clover shape, or it has what? Or it has the 2 dumbbells, excuse me, with the donut in the middle. Now we'll move on to question number 10. Here is where I wanted to read. So I'm gonna write a very quick summary of the full compounds chapter in AS chemistry, okay? Let me open my summary. So, what do we need to know from this AS chemistry? We need to know the reactions of what? Of group 2 with the water, with oxygen, with H2SO4, and with HCl. And we also need to know what happens as we go down the group, meaning their properties as we go down the group. Let us first start with the reactions. Let me write R with water, which is what? Which is H2O. When reacting with water, we have many different possibilities, okay? We have what? We have that either it's a metal that's solid, will react with H2O that is a gas to give us what? A metal oxide that is solid, plus what? Plus H2 gas. However, there's another equation, which is metal solid reacts with H2O liquid to give us a metal hydroxide, okay, which is, depending on the level, will be aqueous or solid, in addition to what? In addition to hydrogen gas. So this is not balanced. How do we balance this? Very simply by putting a 2 over here. Now, when do we react with gas and when do we react with liquid? Very simply, the only 2 group 2, remember this is what? Group 2. The only 2 group 2 elements that react with gas are Pe and Mg. This is, we're talking water gas. And then the rest, including magnesium, because magnesium is both liquid and gas, water. So magnesium, Ca, Sr, and Ba will do what? And then for the MOH2, based on the level on where they are in the reactivity, or like as you go down the group, we will see whether it's solid or aqueous, okay? So this is the condition, first of all, with water. So reaction with H2O, if it's gas, the only 2 that react are beryllium and magnesium. So metal will react with hydrogen, water that is gas, to give us a metal oxide that's solid and hydrogen gas. However, metal will react with 2 hydrogen water, 2 H2O liquid, to give us what? 2 hydrogen water, my bad, 2 H2O liquid, to give us what? metal hydroxide, which we will denote later if it's solid or aqueous, in addition to H2 gas. Okay, so this is all you need to know for the reaction with water. Now, reaction with oxygen, O2. I think it's for all of them the same. It's 2 metal plus O2 will give us what? Will give us 2 metal oxide. Okay? Usually metal is solid, oxygen is gas, and metal oxide is what? Is a solid. So 2 metal solid plus oxygen gas will give us 2 metal oxide solid. So this is the reaction with oxygen. Now we move on to reaction with H2SO4. Okay? Here we have one homogeneous equation, like one only equation. However, we need to know whether it's gonna be aqueous or if it's gonna be solid. So what is the general equation? It is the metal solid will react with H2SO4 aqueous, okay? To give us what? To give us metal SO4, which we will denote if it's aqueous or solid, plus what? Plus H2O gas. Now, if it is beryllium or magnesium, it's directly aqueous. However, excuse me, if it is calcium, strontium, or barium, it's directly what? It's directly solid, okay? So this is the conditions you need to know for H2SO4 reaction. So please remember this. Now, the last thing to talk about is what? Is HCl, the reaction with HCl. It's metal solid plus 2HCl aqueous. Will always give us what? Will always give us MCl2 aqueous. It's always aqueous. In addition to what? In addition to hydrogen gas. So please remember the reaction with hydrochloric acid, okay? HCl. So that is it for the reactions. Now, what happens if we go down the group? As we go down the group, how do we go down? Beryllium, magnesium, calcium, strontium, barium. So as we go down, the atomic radius increases. The first ionization energy decreases. The melting points decrease, and the reactivity, of course, depending on whether it is SO4 or hydroxide or whatever, it depends. But let us say reactivity with SO4, as you go down the group, it decreases, whereas reactivity with hydroxide OH2, as you go down the group, it increases. Okay, so this is all we need to know for these topics. Now let's get on with solving. So magnesium solid plus hydrogen liquid, a metal plus hydrogen liquid will give us a metal hydroxide, and in this case it's magnesium. So magnesium is gonna be what? It's gonna be aqueous, as well with the fact that it releases H2 gas. Now, reaction magnesium solid plus H2O gas, a solid metal, group 2 metal plus hydrogen gas will give us magnesium oxide, metal oxide, in addition to H2 gas. Now, we need to write the chemical equations, including their state symbols in the equation, in order to do what? In order for us to solve the question correctly. So let's start over here. You need to react what? You need to react magnesium solid with all of the following species. So we covered how to react a metal solid with HCl aqueous, H2SO4, and O2 gas. First thing we do is we write Mg solid, Mg solid, Mg solid, and Mg solid, okay? So magnesium solid will react with, what was the equation again? Metal solid plus 2HCl, okay? Which is what? What is HCl? HCl is aqueous. Will give us what? It will give us metal Cl2, so in this case MgCl2 aqueous, okay, because they're always aqueous with chlorine, in addition to what? In addition to hydrogen H2 gas. Now, this is metal solid. Metal solid, okay? Now, we're dealing with what? We're dealing with H2SO4, which is the sulfuric acid. So remember, we said what's the general equation? Metal solid plus H2SO4 aqueous will give us MSO4 metal sulfur, MSO4 in addition to hydrogen gas. Now, the only ones that are aqueous are beryllium or magnesium, whereas the rest are, excuse me, they are solid. Okay, so it's magnesium solid in this case. In addition to what? In addition to H2SO4, which is aqueous. Remember, H2SO4 is always aqueous. Okay, will give us what? It will give us metal, in this case, which is magnesium SO4. In addition to what? Excuse me. In addition to hydrogen gas. Now, what is the state symbol of MgSO4? Because it's Mg, it's gonna be what? It's gonna be aqueous. If it was Be, it would be aqueous. But if it's Ca, Sr, and Ba, they're gonna be solids. Now, last but not least, magnesium with oxygen. We said when we react a metal with oxygen, what's the equation? It's 2 metal plus oxygen O2 will give us 2 metal oxygen. So 2 metal magnesium solid plus O2, which is what? Which is a gas, will give us what? Will give us 2 metal oxide, or 2 MgO in this case, solid. Perfect. We finished question 10. We'll move on to question number 11. This is really easy. If this is protons, that means it's going towards this plate. That means this plate is negatively charged, meaning it's a negative plate. B is neutrons because they are not deflected. So if this is protons, what leaves us for A? Electrons. And if A is electrons, that means X is the positive plate. Okay, so what is X? Again, X is the positive plate. Excuse me, I'm a bit sick. Please ignore my coughing. Y is the negative plate. A is what? A is the electrons. And B is the neutrons. Now, you should know these. The electron is what? Is a subatomic particle. It has a symbol of E-. It has a charge of -1 and its relative mass is 1/1836. Neutron has a symbol which is N0. It has a charge of 0 and it has a mass of 1. Proton has a charge of +1. It has a unit of, or a symbol of P+, and it has a mass of 1. Let's move on to question number 12. What did we say? We said as we go down the group, melting points decrease, right? That means if you look on the periodic table, BA is lower than CA, so it's down the group, down farther the group than CA. That means it will have what? It will have a lower melting point. Whereas we said as we go down the group, atomic radius increases. So BA is lower than CA. That means BA has a greater atomic radius than CA. Now, as we go down the group, first ionization energy decreases. That means first ionization of energy of BA is less than that of CA. And then finally, the reactivity in general of BA. As we go down the group, the reactivity excuse me, it increases. So in this case, the reactivity of BA is greater than the reactivity of CA. Now, X was analyzed and the percentage by mass of BA is 81.1%. X reacts with dilute H2SO4 in a 1:1 ratio. Okay, this is important for later, that it reacts in a 1:1 ratio. Now, how do we find compound X? We know that barium is strongly heated in oxygen. So we have many options to write. We can say it's BaO or it's BaO2. But how do you know which is which? This for sure is not the answer. I will tell you why now. If you were to try BaO, okay? Take the mass of BA, which is 137.3, and you will divide it by the total mass of BaO, which is 16 plus 137.3 times 100. You will get what? You will get 89.6%. Which is not what we need. Us, we need 1%. So this is wrong. If you did this one, 137.3 over 16 times 2 plus 137.3 times 100, you are gonna get 81.1%. Now, because of this, we know what? We know that the compound X is BaO2. Okay? And this is how you solve for BaO2. Now we move, we move on to the rest. So just the formula for compounds Y and Z. First of all, Y is solid, meaning there is a salt that is formed between barium dioxide and H2SO4. In my opinion, look what I will do. I will do BaO2 plus H2SO 4. And then I separate into their ions, Ba2 plus, right? O2 minus, but in this case it's 2O2 minus, plus H plus, in this case it's 2H plus. Actually, no, my bad, it's not 2O2 minus, it's actually O minus, okay? So it's O minus, and it's 2O minus, plus 2H plus, okay, in addition to SO4 2 minus. Again, what did I do? I separated them into their ions. You can do the crisscross method. This is gonna be Ba2 plus, then O minus, and then since O is multiplied by a 2, you'll have to multiply it here. Same thing here, separate. You'll have SO4 2 minus and H plus, but because H is multiplied by a 2, you'll have to multiply it over here. So now, in my opinion, you will take the positive and mix it with the negative of the other one. Take the positive, mix it with the negative of the other one, and what are you gonna get? You are gonna get very simply BaSO4 in addition to H2O2. So BaSO4 in addition to H2O2. So Y is what? Y is BaSO4, and then Z is what? Is H2O2. Perfect. Let's now move on to question number 13. What does it say in question number 13? Now, choose the correct answer to identify the general trends as we move down group 2 in the periodic table. As we move down group 2, the reactivity of element increases, the melting point decreases, the first ionization energy decreases, and the atomic radius, what it increases. Okay, now what did they ask us in part B? Write the chemical equation between calcium and oxygen gas, including the state symbols. What is the equation of group 2 metal with oxygen? It's 2 metal solid plus O2 gas will give us 2 metal oxide solid. So 2Ca, this is 2Ca solid, in addition to excuse me, O2 gas is gonna give us what? Is gonna give us 2CaO. What? 2CaO solid. Now, perfect. Drag and drop the following saturated solutions of hydroxide to arrange them in increasing order of pH value. So this is their order: SrOH2, CaOH2, and MgOH2. Why is this? Because as you go excuse me, as you go down the group on group 2, the reactivity of hydroxides increases, right? So as the reactivity increases, that means they're gonna break down more. If they're gonna break down more, they will release more hydroxides, and when they release more hydroxides, that means their pH value is gonna increase, because hydroxide will increase the value of the pH. Okay, now what type of compounds do calcium and barium form, ionic or molecular? Now, for sure, calcium and barium are metals. So whenever you think of metals, you think of ionic compounds. Okay, they didn't tell us metallic, so you cannot take that into consideration. We only have ionic or molecular. For sure, the metals don't form molecular compounds, but they do form ionic compounds. Now, this one, I think it's wrong. The correct answer is supposed to be brick red color for calcium and scarlet color for strontium. Now, it's going to tell me wrong for question 13, but this is the correct answer. Move on to question number 14. Elements in group 2 are known as alkaline, blah, blah, blah. Choose the correct excuse me, answer to identify the general trends as we move down the group 2 in the periodic table. As we move as we move down group 2 in the periodic table, what happens? The charge of their ions remains constant. Why is this? Because if you take the charge of any group 2, you have Be, Mg, let's say, and Ba. What are their charges? Ba2 plus, Mg2 plus, Ba2 plus, so it's always the same. It remains constant. Now, as you go down the group, the density increases. Why? Because the mass is increasing. So at a constant volume, if the mass increases, that means the density increases. As we said as well, the first ionization energy decreases and the atomic radius increases. Now, elements of group 2 burn in air rapidly forming oxides. Group 2 oxides react with water to form hydroxides. Now, write the chemical equation between magnesium and oxygen gas. What did we say before? We said that when it's a metal with oxygen, but it's a group 2 metal, what's the equation? 2 metal solid plus O2 gas will give us 2 metal oxide solid. So in this case, what's our metal? Our metal is magnesium. So 2 magnesium solid, okay, plus O2 gas is gonna give us what? It's gonna give us 2 magnesium oxide solid. Perfect. Now, hydroxides. As we go down the group, hydroxides get more and more soluble. That means if we're gonna put them in increasing order of solubility, BaOH2 has a greater solubility than CaOH2, which has a greater solubility than MgOH2. Again, as we said, strontium and barium, they are both group 2 metals. Since they're metals, they form, in this case, ionic compounds. Now, finally, strontium has a scarlet color, okay? And barium has an apple green color. Let's move on to question number 15. What does it say in question number 15? Okay, this is an element, right? It has 12 protons. Let's look on the periodic table. Which element has 12 protons? Magnesium. Okay, so it's magnesium. 12 neutrons, okay. And how many electrons? 10 electrons. So how do you do the charge? The charge is the number of protons, or the atomic number, minus the number of electrons. Then minus 2 is what? Is 2 plus. So it's Mg2 plus. Let's move on to the next one. 38, let's look which one has 38. Strontium, Sr. Okay. Neutron is this electron. What's the charge now? It's 38 minus 36, which is 2. So strontium 2 plus. So what are the answers? Magnesium 2 plus and strontium 2 plus. We move on to question number 2. What does it say? In question number 2, it says the solubility of group 2 hydroxides. Okay, as we go down the group, the solubility of group 2 hydroxides increases, whereas for sulfates, as we go down the group, the solubility of group 2 sulfates decreases. In general, reactivity of group 2, as we go down the group, it increases, okay? Now, consider a solution of strontium hydroxide of the same concentration at the same temperature as MgOH2 solution. Choose the correct answer. pH of strontium OH2 is what? Okay, we said as we go down the group, the solubility of hydroxides increases. So the more soluble that it is, the more it will break. The more it breaks, the more it releases hydroxide. The more hydroxide it releases, the more higher the pH will become. So in this case, strontium is less, or like downer in the group, or lower in the group than magnesium. That means it has what? It has a greater solubility of hydroxide. So that means the pH is gonna be what? The pH is gonna be bigger as there's more hydroxide being released. Now, look what they are telling us over here. Magnesium, Mg, is being heated in air, in O2, right? So anytime we add oxygen to a metal, okay, we'll need to apply the rule, which is what? Which is 2 metal plus oxygen. O2 is gonna give us what? Is gonna give us 2 metal oxide. So it's 2 Mg plus O2 will give us 2 MgO. Now add liquid water to a metal oxide. Whenever we're adding water to water plus oxide, whenever we're doing water plus oxide, what will we get as an answer? We will get a hydroxide as an answer. So in this case, water plus magnesium oxide, it's gonna be what? It's gonna be magnesium hydroxide, okay? So again, 2 Mg solid plus O2 will give us 2 MgO, okay? I don't think they want the 2, so you will just write it as MgO. This is R. And then for you, anytime you will add water to an oxide, you will get what? You will get a hydroxide. So how about you add water to a magnesium oxide, you will get magnesium hydroxide. So it's gonna be MgOH2. Okay, so MgO and MgOH2. We move on to the next one. What does it say? Chemical formula of the compound produced. What are they telling us? They are telling us that we took U, okay, and we added it to HCl, HNO3, and H2SO4. Each of these are what? Each of these are acids. So in our case, MgOH2 is what? It's a base. Whenever you add a base and an acid, you will get what? A neutralization reaction, which releases salt and water. So in this case, water is what? Is one of the products, but the compound produced is the salt. How do we find the salt? Very simply by taking the cation of U in this case and adding it to the anion of HCl, HNO3, and H2SO4. So, for example, MgOH2 in addition to what? In addition to HNO3, right? Separate them into their ions, Mg2 plus, OH minus, H plus, and NO3 minus. What do we do now? We remove these because OH minus and H plus will give us what? They will give us water. And then NO3 minus and Mg2 plus, what will they give us? They will give us Mg, NO3, 2. Okay, this is just an example of how to do it. So Mg, NO3, and then don't forget to put the brackets as well. Very important. 2. Same exact thing with HCl. It's gonna be what? It's gonna be MgCl2. And same exact thing with H2SO4. It's gonna be what? It's gonna be MgSO4. Perfect. That's it for the first part. Let's move on to the next one. State the state of the compound produced. Always the state of the compound produced is aqueous, of course, if it's Mg, okay? Whenever you see Mg, you remember it's aqueous. However, if it's SO4, okay, and it was what? If it was calcium, strontium, and barium, they would be solid, okay? They would not be aqueous. But in this case, because it's Mg, it's gonna be what? It's gonna be aqueous. Aqueous and aqueous. Perfect. Now, numerical ratio of the reaction of U with the acid. In my opinion, no need to get too complicated into this. What I would do if I was you is I would look at the thing that's in common between both of them. So HCl and MgCl2. NO3, NO3, 2. SO4, SO4. Here, this is 1, and how many chlorines you have? 2. This is 1 NO3, how many do you have here? 2. This is 1 SO4, this is 1 SO4. So what are the ratios? The ratio is 1 to 2, 1 to 2, and 1 to 1. Okay? So 1 to 2, 1 to 2, and 1 to 1. Now, finally, when U is added to excess HCl, okay, followed by what? Na2CO3. Whenever you see CO3, you will remember what? You will remember another equation. You could do it like this, or you could do it like how I could do it. We can say that, okay, what do I have now? After I added HCl, I got what I got? MgCl2. Okay, it's aqueous. Then they added for me what? They added Na2CO3. So now let's separate them into their ions. You're gonna get here Mg2 plus, Cl minus, Na plus, CO3, 2 minus. Now, I take the negative with the positive of the other one. So this one, I take it with this one, and this one, I take it with this one. What do I get? I get MgCO3. Why? Because you have to do the crisscross method. You guys should know how to do the crisscross method. I get MgCO3 and what? An NaCl. Now, this is aqueous, whereas MgCO3, I believe it's gonna give me a what? It's gonna give me a compound. And this is what? This is the compound which they need from me, which is what? Which is MgCO3. Now we move on to the next one. Radium is below barium. Because radium is below barium, we know that it's down the group. So again, as we go down the group, density increases. That means density of what is it called? Let me just fix this. Density of radium is greater than that of magnesium. As we go down the group, melting point decreases. That means melting point of radium is less than that of magnesium. As we go down the group, atomic radius increases. So atomic radius of radium is greater than that of magnesium. And then second, ionization of energy decreases. So that of radium is less than that of magnesium. Let's move on to question number 17. What does it say? Now, radium sulfate is what in water. Remember, we said as we go down the group, solubility of sulfate decreases. So if in calcium, strontium, barium, it is a solid, that means in the radium, which is even lower in the group, it's gonna be what? It's gonna be a solid or insoluble in water. Now, here we need to find what the oxidation number. So here what I do advise is to solve it like this. For example, I don't know what is the oxidation number of Ra in this case. I'll say it's X plus 2 times Cl. Cl is -1 is equal to the charge. What's the charge in this case? It's 0. So X minus 2 is equal to 0. X is then equal to plus 2. So the oxidation number is plus 2. For Cl, in this case, we know that it's -1. Radium by itself is 0 and Cl by itself is 0. Remember, elements are always 0. Unless it's a compound of 2 different elements, then yes, it's going to have an oxidation number. If it's not a compound with 2 different elements, then it's not going to have an oxidation number. So this is going to be what? 0 and 0. And this is going to be plus 2 and -1. Now we move down here. Radium is the what? So radium is the oxidizing agent. Why? Because it is gaining electrons. And we know that the gaining of electrons is reduction. So that means what? That means the radium underwent reduction. How do I know? Just remember oil rig. What is oil rig? Oxidation is loss, reduction is gain. Okay? So reduction is a gain of electrons. I gained 2 electrons. That means Ra underwent reduction. So it's what? It's the oxidizing agent. Now it's the opposite for Cl. Cl lost an electron. That means it was oxidized, and because it's oxidized, that means it's the reducing agent. Now, solubility of sulfates. As you go down the group, solubility of sulfates decreases. Whereas if you go down the group, reactivity of group 2 metals increases. Now, the reaction of radium with water is vigorous. So again, what did we say? We said as we go down the group, reactivity increases. So for sure, reaction of radium with water is vigorous. Now, what do they need from us here? Do not forget to include state symbols for what? The reaction of radium with water. Remember, we said that the only 2 metals that will react with steam, which is water as a gas, is beryllium and magnesium. So since we're dealing with the radium, that means it's going to be what? It's going to be radium solid based on the equation, metal solid, in addition to H2O, water, liquid, okay, is going to give us what? Is going to give us the radium hydroxide, RaOH2, in addition to what? First of all, this is aqueous, okay? In addition to what? In addition to hydrogen, H2 gas. Now, you have to balance it by putting a 2 over here, okay? Now, again, radium, because it's not beryllium and magnesium, it's going to react with water as a liquid. So you have to follow the equation, which is metal plus 2H2O liquid is going to give us metal hydroxide in addition to hydrogen gas. Now, the solution produced upon reaction of radium with water has what? Has a pH close to 12. Why? You always choose the highest number when it comes to pH in hydroxide, because hydroxides will break down, okay, and they will release so the metal hydroxide, in this case RaOH2, will break down and will release the hydroxide, which will give us an answer of what? Which will give us which will add more to the pH, so that you will have to choose what? The highest answer. So this is really easy. If it deviates away from the positive plate, positive and positive repel, so it's proton. If it deviates away from the negative plate, negative repel, it's electron. And if it doesn't deviate, it's neutron. Question number 19. Very easy. The relative charge of the proton is +1. Neutron is 0. Electron is -1. Relative mass is 1 over 1836. And then for these two, it is 1. We move on to 20. What's the number of protons of bromine? You have to check. It is 35. Number of neutrons is 80 minus 35, which is 45. And number of electrons, since it is an atom, it is going to be what? It's going to be 35. 21, here you have to remember the shape of the orbitals. This is an s orbital. This is a d orbital, which is either clover shaped or the dumbbell with a donut in between. And the p orbital is what? Is a dumbbell. 22. Okay. They're asking us for what? For the maximum number of electrons that can occupy the 4th energy level. How do you find the maximum number of electrons that can occupy the 4th energy level? So what is the equation for maximum number of electrons? It is 2 times n squared. So what is n? N in this case is the level of energy. So in this case, just substitute level of energy. 2 times 4 squared. That's going to be what? That's going to be 32. So 32 electrons. Move on to question number 23 now. What has a maximum of 10 electrons? It's the D subshell. Why? Because D subshell has 1, 2, 3, 4, 5, right? Or you draw one big box and separate it into 5. And then each one has two electrons or one pair of electrons. So if that's the case, if each box has 2 electrons, then that's going to be 2 times 5 boxes, which is 10 electrons. Question number 24. Given the below mass spectrum of a sample of unknown element, choose the number of isotopes. So what are you going to do? You're going to count either the mass numbers or how many lines there are or how many percentages there are. In total, you have 3 isotopes. Now, what is the relative average mass? How do you find? My bad. The relative average mass, very simply, the relative average mass, it's the mass multiplied by its percentage. Plus 25 times 10%. Plus 26 times 11%. 24 times 79%. Plus 25 times 10%. Plus 26 times 11%. What will you get? You will get an answer which is approximately 24.3 grams. This is the relative average mass. Now, check in the periodic table and you will see that it is what? It is magnesium that has a relative average mass of 24.3. Number 25, naturally occurring boron is composed of 2 isotopes, B10 and B11. They gave us the average atomic mass. They want us to find the percentages. So we know that it's going to be 10 times X%, right? Plus 11 times 100 minus X%. Why? Because these 2 percentages, or as many percentages as they are, you add them all, they're supposed to equal to 100%. Okay? So this is equal to what? It's equal to 10.81 AMU. So what I prefer to do in this case is to write it as a fraction. So 10x over 100 plus 11 times 100 is 1100 minus 11x over 100 is equal to 10.81. You can combine these denominators to make one big one. And you can move it to the other side, right? Once you move it to the other side, let me bring it here, equals 10.81. You can move it to the other side. When you move it to the other side, you're going to get 1081 is equal to this. Move this to the other side. Then you will you will get minus 19 is equal to minus x. That means x is equal to 19%. Okay, so now we have the value of x, which is 19%, and it corresponds to B10. What is left for B11? It's very simply 100 minus 19, which is what? Which is 81. So 19% and 81. Move on to 26. They want the relative charge of the nucleus. This is the number of protons in the nucleus, and you always add a plus. So plus 90. Okay, so the answer here is plus 90, not 990, plus 90. Okay. Now, we move on to question number 27. This is very easy. Just write TH here, 232, and 90. Move on to question number 28. Write the shorthand electron configuration of the following atom. First of all, I recommend you write it all. So, Fe. So, what is the atomic configuration of Fe26? It is very simply 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s2, 3d6. So what is left? The last thing left is to write it as a shorthand electron configuration. So you look at Fe. Where is Fe? Fe is, okay, I found Fe26. Look on your periodic table. Where is Fe26? Now, see what is the noble gas directly before, not after, before Fe. In this case, it's argon. And how many electrons does it have? It has 18 electrons. So this in total, which is 18, will be simply replaced by argon. And what's left to write? 4s2, 3d6. Okay, so argon, 4s2, 3p6. Perfect. Let's move on. Argon, 4s2. Write the shorthand electron configuration for the following ions. Okay, so this is something different they want for the ions. Again, Ti is how much? How many does it have? Ti, it has 22. So let's do the electron configuration of 22. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, that's 20 already, and then 3d, 3d2. Alright, perfect. So now what are we gonna do? Now you will go to Ti, you will find where is Ti. I found Ti, and you will see what's the noble gas directly before it. It's argon, so it has 18 electrons. You will substitute all of this by argon. Now, what did they say? It's Ti2 plus, so you are removing 2 electrons from the nearest s2 orbital. So you will remove 2 electrons here, and what is left for you to write? 3d2. So you will go to the last s orbital, or the nearest s orbital, which in this case is for s2, and you will remove all of the electrons from there. So what's the final answer? It is argon 3d2. Now finally, phosphorus 15p3 minus. We need to write the electron configuration, so it's going to be 1s2, 2s2, 2p6, 3s2, and 3p3. Okay, so this is the electron configuration of phosphorus, right? You see, where is phosphorus? I found phosphorus. What's the noble gas directly before it? It's neon. So all of this will be replaced by what? It will be replaced by neon. So what's left for me to write is 3s2, 3p3, but I will add 3 electrons, so it's gonna be 3p6 then. Okay, so neon, my bad, 3s2, 3p6. And now finally, question number 30. Removing a 1s electron from oxygen requires more energy. Why? Than from nitrogen? Because oxygen has a higher nuclear charge. The higher the nuclear charge means the more protons there are. The more protons there are means there's a greater, stronger attraction. And due to the stronger attraction, it's harder to remove a 1s electron. So let's submit. Hopefully we don't have any mistakes. I think only 13 will be considered. So perfect. Thank you guys for watching. I hope you enjoyed and have a wonderful day.